up here? This chapter has led a lot of students question their life choices, and in fact has sent a lot of grown-ups crying to their moms. But trust me, after this video, you'll become a trigonometry ninja, or well, you'll still hate it, but you'll at least pass. Let's dive into it. So look at both the sides, left hand side as well as right hand side. Always try to start off with a place which looks more complicated. In this question, the left hand side looks more complicated, but the first question actually is simple because it gives them a lot of hints. What are the hints? The cubes are given. So in simple language, I'll straight away start applying a cube plus b cube, which is given by a plus b. You're supposed to write this in your exams. But to start off, since I'm starting with the left hand side, you will also write LHS and then only start. Or else it won't make sense. So sin theta plus cos theta, which is nothing but a plus b into, the formula is a plus b into a square plus b square minus ab. Opposite the sign of whatever is there in the brackets. Getting it? So it will be sin square theta plus cos square theta minus ab. Sin theta into cos theta. Whole thing divided by whatever I copy paste that. Sin theta plus cos theta. Now, what was remaining as it is? The second part, which I copy paste as it is. Now, what mistakes to avoid? I've seen a lot of people trying to write the RHS throughout the question. That's peak dumbness. You're trying to prove something. You start with your left hand side, so you want to trust the process. Go till the last step, simplify as much as possible, and then maybe find an answer. Now, obviously, there are two parts right now. Second part can't be simplified. Look at the first part. This part and this part gets cancelled. Here, do you think I'll be able to apply our trigonometry identity which says sin square theta plus cos square theta is what? Is 1. So you write the 1 as it is minus sin theta cos theta also as it is plus sin theta cos theta as it is. Obviously, minus and the plus gets cancelled. What remains is nothing but 1. After this, you obviously write RHS, hence proved. That's how simple it is. So rule number 1, always start off with a side which looks more complicated. Let's look at the same rule. In fact, that's a good example. In fact, almost all the questions in these videos are board exam questions. Fine. Now again, both sides, which one looks more complicated? Obviously here, left hand side. So you should write that first. LHS has been specified. Now I can see a lot of squares. Second hint, wherever you find a lot of squares, you're supposed to use identities. Just like the way I found a cube and I still applied an identity here, same concept here also. Wherever you find a square, try to apply an identity. Okay. Now, sin square theta minus 1 is there. Don't you think there's a famous identity talking about sin square theta? So, sin square theta plus cos square theta equals 1. Correct? Now, so but it says sin square theta minus 1. No problem. The plus 1 comes this side becomes minus 1. But in fact, the plus cos square theta goes to the other side, becomes minus cos square theta. So after applying my identity, the first bracket becomes minus cos square theta. Rules. You're supposed to always specify the identity which you guys used. So after, by the end of the step, you're supposed to open a bracket and write the form. Okay, very important. Similarly, tan square theta plus 1 is there. Very famous formula again. What does it say? 1 plus tan square theta equals secant square theta. So I'll write here secant square theta, and just like this one, you're supposed to write the identity at the end of the step. Plus 1 was there, I'll copy paste the plus 1 as it is. Please don't write equal 0. It is my job to prove if it is 0 or not. Now, minus cos square theta, I can't simplify it much. Why? It is one of the basic ratios. Again, there are only two basic ratios, namely sine as well as cos. One is there, so I can't simplify it, but everything apart from these two are derived ratios, which means you still have an option of trying to convert them into basic. Look at this for a second. Secant square can also be written as 1 by cos square theta. 1 by cos square theta. If you're still that kind of student who is still, who does not know secant square or cosecant square, very simple. I'm pretty sure everybody's heard of this game called Counter-Strike. During that time, it was the number 1 game. Okay, so that's your hint. Counter-Strike was the number 1 game. This is a hint. Fine. So, depending on your question, you guys keep changing. For example, in this place, secant square theta was being used. Secant starts with s. So keep only the s on the left hand side. Shift the c to the denominator. It becomes 1 by c. Secant square theta equals 1 by cos theta. Secant square becomes 1 by cos square. Secant becomes 1 by cos. So what's the hint? Counter Strike at that point of time was the number one game. That's your hint. I apply the same concept here. Gets cancelled. -1 was there. +1. The answer is 0. This is the RHS. Hence proved. That's it. This hint useful. Next one. Let's talk about this. 1 minus sin theta 1. Again, same rules. What looks more complicated? Left hand side. Now, obviously, look at the right hand side. The denominator is 1, which means it is in this most simplified form. But my left hand side here has some kind of things here. So, what do we do at this point of time? Very simple. We start off by taking the LCM. I am trying to simplify the denominator. The only method I know at this point of time is by taking LCM. So, the LCM, how do you take? You multiply both of them. So, you write it 1 plus sin theta into 1 minus sin theta. Okay? Obviously, you crisscross on top. Regular LCM. So it becomes 1 minus sin theta as it is, a big plus in between, 1 plus sin theta. In the numerator, this is my left hand side. Obviously, I forgot, right? In my numerator, I can cancel the plus and the minus sin theta. 1 plus 1 remains, which is nothing but 2. I'm almost there. I got the number. Okay. I'm supposed to convert the remaining things in terms of secant square theta. Let's see if it is possible. Don't you think the denominator is in the form of a plus b into a minus b, which is nothing but a square minus b square? I'll apply the same logic here. So a square is 1 square, which is nothing but 1, minus sine square theta. Just now we learned a concept about identity. So what was that? Sine square theta plus cos square theta equals 1, which means 1 minus sine square theta will be equal to cos square theta. So this is nothing but 2 by cos square theta. But I could have stopped here, but the problem is the question says the answer has to be in terms of secant square theta. So I'll go one step ahead. I'll keep the 2 as it is. 1 by cos square. Just now we learned the hint. Becomes secant square. So we write the answer as 2 secant square theta. This will be your RHS and hence simple. Next one. Again, the right hand side, the denominator is being simplified. But what looks more complicated? This itself, the left hand side. 1 plus sine the theta the whole square, 1 minus sine the whole square. It is so obvious. We'll have to apply the identity directly. Let's see. So it becomes a plus b the whole square, which is nothing but a square plus b square plus 2ab plus as it is a square plus b square minus 2ab. Whole thing divided by 2 cos square theta as it is. Again, I forgot to write one step. What is the step? LHS. Getting it? Now, what amount can get cancelled? I can see these two things getting cancelled. Obviously, 1 plus 1 and the sine square theta, the sine square theta is remaining. Cool, we'll do it. So it becomes 1 plus 1 is 2 plus 2 sine square theta. Whole thing divided by 2 cos square theta. Now we are almost there, don't get confused. Because let's try to understand a concept here. Somewhere in your, I think 7th or 8th grade math, you know, thought of this, a plus b whole thing divided by c. If this is a concept, it means c belongs to both the parts, which is nothing but a by c plus b by c. I'll apply the same logic here. The 2 cos square theta, in simple language, the denominator belongs to both the parts. So I'll divide it. So it becomes 2 divided by 2 cos square theta plus as it is 2 sine square theta by 2 cos square theta. Obviously, 2 gets cancelled. 1 by cos square theta is remaining, which is nothing but secant square theta. The plus remains as it is. The 2 cancels out. Sine square by cos square gives me tan square theta. This is your RHS, hence proof. That's it. Now again, what looks more complicated? Left hand side looks more complicated. What can be done? LCM can be taken. Take the LCM. So it will be, again, I am starting with the left hand side. 1 plus secant theta it is. After crisscross, it becomes 1 plus secant theta plus tan square theta. Again, think 1 plus tan square theta, I know an identity. I could have done for 1 plus secant theta also, but it's just that I don't know any identity. For 1 plus tan square, I do know one. 1 plus tan square theta according to identity becomes secant square theta. I use this up and I will figure out something. So this becomes secant square theta plus secant theta. In the numerator, 1 plus secant theta remains as it is. Obviously, in the numerator, since both of them are secant, we know a rule that we will be able to take common things out. So the common thing becomes secant theta. After taking common, secant theta remains plus 1 remains. Whole thing divided by 1 plus secant theta remains. Automatically I can cancel this and this. While a plus b or b plus a both mean the same thing. What remains? Secant theta remains. That's exactly what I wanted on my right hand side. Therefore, this becomes my RHS and hence proved. No any shortcuts, sir. You gotta write the complete thing, hence proved. Next question. Left hand side. Again, here I can see cot and tan, but your answer is in terms of sine and cos, which means even though your left hand side has derived ratios, your right hand side is demanding them to get converted in terms of basic ratios. You're supposed to do it. So what do we do? I write the sine A as it is, divided by 1 by cot in terms of basic ratios is nothing but cos by sine. I'll write it here. Similarly, the minus as it is, cos A as it is by 1 minus sine A by cos A. What has to be done next? Both the parts start taking LCM. So it becomes sine A as the LCM here. Sine A plus cos A in the denominator. Numerator sine A remains as it is. Minus, I take LCM here also, but the LCM here is cos A divided by cos A minus sine A by cos A. We always know that denominator becomes the numerator. I repeat that, denominator always becomes the numerator. I'll flip it. So this sine A goes on top, gets multiplied, becomes sine square A, but the denominator remains as it is, sine A plus cos A. Correct? Same thing here. Minus cos square A by cos A minus sine A. Now what I do here is, both of them are almost the same. What's the difference? The negative, the sign is the change. So what I do, I copied the question wrong. So this becomes a plus throughout. I change it to be a plus. Now I take LCM. So it becomes sine A plus cos A. Numerator becomes sine square A minus cos square A. A square minus B square in the numerator is nothing but A plus B into A minus B by whatever is there as it is. What gets cancelled? The common part gets cancelled. This is your answer as your right hand side. That's it. Next question. 1 minus tan A. Basic thing is we will try to convert everything into the derived ratios to basic ratios. Let's do it. So it becomes 1 minus sine by cos whole thing divided by 1 minus cos by sine. You take LCM in both the parts, it becomes cos A minus sine A by sine A minus cos A by sine A. Regular stuff, don't forget the squares. Don't forget the squares. Now what do? We apply the same concept right now as I told you. Denominator becomes the numerator. So it just flips, and if you're getting confused with that, I'll rewrite it, no worries. Cos A minus sine A by cos A into, it flips, sine A on top and sine A minus cos A the whole square. Now I want to cancel it. That is very tempting to me, but the signs are not fine. So what do? I take minus common, no problem. I take minus common. After taking common, it becomes sine A minus cos A. Okay, by cos A is anyways there, sine A is anyways there. The same thing is anyways there. We gotta take it off. Now obviously we want to take what about the negative sign. Don't worry, the square, no. So right now minus sine A by cos A remains. So the answer is minus tan A. Minus tan A the whole square becomes what? Plus tan square theta or tan square A, whatever. Okay, I took A everywhere, so I'll change the question to A itself. Okay, so it becomes minus tan, the negative can be taken out. The reason I'm playing on this is because I have a square. Negative square always becomes positive. So the answer becomes tan square A or tan square A, theta, whatever. This is your RHS, hence proved. Write that. Look at this left hand side. Looks more complicated. So we start off with that one. Cosecant theta is nothing but 1 by sine theta. Or sine theta, yeah. Minus sine theta as it is. Same thing here. I'm converting everything in terms of basic ratios. And are these the only ways to solve this? Obviously no. Obviously no. There can be multiple ways. 1 by cos theta minus cos theta as it is. Convert this also in terms of basic. Sine by cos plus cos by sine. But I'm more interested with the first two brackets itself. I take LCM. So LCM becomes sin theta becomes 1 minus sin square. Okay, here, careful, becomes 1 minus cos square. Here it becomes sin theta into cos theta by sin square theta plus cos square theta. Now see the amount of changes we'll be making here. 1 minus sin square is cos square, careful, by sin theta as it is. I take off the bracket and put it into. 1 minus cos square is sin square by cos theta. Now see everything gets cancelled. Sin square theta plus cos square theta, the answer is 1. How identity? Sin into cos is remaining there. Cos theta once and the power gets cancelled. Sin theta once, power gets cancelled. Sin cos gets cancelled. 1 remains. Simple. Next. Okay. What looks more complicated? Left hand side. Let's start off with that only. Now there's one secant is there and tan is there, or if cosecant is there and cot is there, 100% identity has to be used. You have no choice. So what do? Secant square theta is nothing but 1 plus tan square theta. I write the thing. What's the only challenge here? The square root. Fine, we'll take care of it. Plus cosecant square is 1 plus cot square theta. Correct. Now obviously, what and what gets cancelled? Nothing is getting cancelled obviously. 1 plus tan square, 1 plus cot square. Cool. Now the answer becomes tan square theta remains plus cot square theta remains plus 2 remains. Now don't you think this is nothing but tan theta plus cot theta the whole square? Obviously tell me, sir, anything a plus b the whole square is a square plus b square plus 2ab. Tan theta into cot theta had to be there, it is missing. That's what you might ask me. But think, tan theta into cot theta is missing. Don't you think cot is nothing but 1 by tan? If you write tan theta into cot theta, the cot gets converted to 1 by tan, the tan and the tan gets cancelled, therefore only the number remains. Keep that in mind. Okay? Now root of tan, the root and the square gets cancelled. What remains is tan theta plus cot theta. This is nothing but your RHS. That's it. Last question. Let me wrap up. Obviously here, what can be done? Try to convert everything in terms of cosecant. Okay, everything in terms of basic. That will give your answer. Anytime you get stuck and it looks like this, the derived ratios, try to convert in terms of basic ratios. 99% of the times you will solve the problem without any hassle. Let's start. 1 as it is. Cot is nothing but cos by sine minus cosecant is nothing but 1 by sine. After the same concept here, tan is nothing but sine by cos plus 1 by cos. First bracket LCM is sin theta. So sin theta towards everything. So it becomes sin theta plus cos theta minus 1. Here cos theta becomes LCM. 1 plus sin theta, plus cos theta. That's the LCM. Okay. Now don't you think, if I put brackets, think properly. Only the numerator is in the form of a plus b into a minus b, where the value of a is sin theta plus cos theta and the value of 1 is b. A plus b into a minus b, where the answer is a square minus b square. A square becomes sin theta plus cos theta the whole a square minus b square is 1. Whole thing divided by, you multiply them, the denominator regularly. So it becomes sin theta dot cos theta. Irrigate. Now obviously you know what to do. We expand it. So it becomes a square plus b square plus 2ab. Okay. Minus 1 whole thing divided by 2 sin theta. Only sin theta, my bad. Becomes sin theta dot cos theta. We've almost got the answer. This answer is anyways 1. 1 and minus 1 gets cancelled. Obviously, what remains? 2 sin theta dot cos theta is remaining. Sin theta and cos theta gets cancelled. 2 remains. That's your answer. Subscribe the channel.